So we are actually, learning this concept, the capital budgeting, right? So far we already completed basic, understanding of capital budgeting. So why you should use capital budgeting?
To understand what will the project is best for us, how can we invest on a particular project or not.
Okay, anyone else?
Identify my equity and debt. Identify my equity and debt.
No.
Sir, I think
Start.
if I have two projects in my hand, which project is more acceptable than other?
Exactly. That basically we actually use capital budgeting to actually evaluate the projects. So if which project is visible or which project is actually feasible to us, that we are going to evaluate by using the different capital budgeting techniques. So what are the capital budgeting techniques or tools?
There are
Seven techniques. What are they?
Discounted calculated multiple IRR. That's a probability index.
Not multiple IRR, IRR.
IRR.
NPV, MIRR, profitability index. Okay. Discounted profit. Okay, so there are basically 7 tools. So there are a lot of debate which tool or tools are best among the capital budgeting tools. So we already come up with the basic understanding. So what we are going to learn today, we are going to actually in a debate of which project, which tool is best, NPV or IRR. In there are different situations, and on the situation, on the base of the situation, we can use NPV or we can use IRR or you can use both. So sometimes IRR actually come up with a negative or misleading information. Sometimes IRR give us the misleading information. So how to solve this problem? So we actually try to figure out this problem, like problems with an IRR approach. So there are 3 issues we already discussed. Is the multiple IRR, one of the problem. That means there are so many projects that will give you 2 IRR. So on the basis of our IRR, we cannot actually take the decision. Say for example, if one project the IRR is say 15%, and another IRR is of the same project is 25%. Okay. So in this connection, we cannot take the right decision. Like if my cost of capital, say for example, my hurdle rate is cost of capital is say 17%. So if my cost of capital is 17%, we cannot take the decision. According to this IRR, we can say, okay, this project is viable, we can go for this. But according to this IRR, we can say this, we cannot go for this project because we can make a 2% loss if we go according to this IRR, right? So that means this is the major problem with the IRR. So you cannot take the decision solely by using IRR approach. And you also know this, borrowing and lending issue. So another misconceptions of IRR is IRR also always take basically the reinvestment rate is considered by IRR. That means IRR always consider that we will going to reinvest our cash flows. Right? Say project is for 5 years, so or 3 years. Say this is our 0 right now, and 1, 2, and 3, 4, and 5. So if I get this cash flow, say cash flow of here is basically, say for example, simple 5,000, and my investment is 10,000. Okay. In past cash flows, if the project, if the IRR of this project is say for example 35%, IRR consider that we are going to reinvest this cash flows in first year with this 35%, which is kind of impossible. And there are you can look at, there are projects where the IRR is 300% or 200% or 250% or 70%. So which is quite impossible to reinvest our cash flows with 70% or 35%. So this is the another mistakes or a problem of IRR. So IRR may not actually give you the right direction. And another one is scale problem. So scale problem is basically if we invest in a mutual exclusive project. Say I have a opportunity to invest only one project, but there are 2 projects available to me, but I can take only one project. So in one project I have to invest, say for example 5 crore taka, another project I have to invest, say for example 7 crore taka. So we clearly see this, there is a scale problem. A scale problem is basically the amount of investment we are going to make that is different totally. So in one project I have to invest 5 crore, another project I have to invest 7 crore. Understand? So in this connection, actually IRR will make you the misleading information. We already covered these things. So today's our topic is basically the timing problem. So if the now question is what is timing problem?
So both investment are same, how will return in after certain time period of time?
No, not exactly. What is timing problem? Anyone else?
Or English is same, but return is every
Exactly. Investment is same. That means there are two projects available to you. The investment is same, but the cash flow will coming to you will be different. So we can look at in Excel file. So see, I already put the information here. So see the timing problem. The project A cost is 10,000. Okay, in year 0, time 0, and the project B cost is same, but the cash flow problem is here is in cash flows. Like in first project, in project A, our maximum cash flow income come in year 1, and year 2 the cash flow is 1,000. In year 3 cash flow is again 1,000. Okay. In project B, if you look at the project B, in first year cash flow is basically 1,000, second year is 1,000, and last year it is 12,000. This is called the timing problem. That means the cash flow coming to your company will be different. Here this 10,000 maximum amount come in the earlier year, and in project B the maximum amount will come in later year. Okay, so in this situation, IRR might give us the misleading information. So look at this project. So what we are going to do, we are going to calculate basically the NPV and IRR of these two projects first, then we will go for the incremental and other issues. So calculate please, okay, NPV and IRR. I can go for the Excel issues. So NPV and IRR. Is it visible to you?
Yes, sir.
Okay, so we are considering basically 10% as a cost of capital hurdle rate. So you already know how to come up with the hurdle rate or cost of capital. So we are using 10%. So write the formula like NPV. NPV. Now we have to give the rate. That means 10%, right? And then our cash flows. Here the cash flows, and plus our cash outflow. So we got our NPV for the first project, that is 668, okay, or 69 if you make it round figure. And same by using the same way we can easily get our NPV of the project B. So you can see that according to the NPV, you can look at here. According to the NPV, you can see the project B is clearly ahead than project A, right?
Yes.
So in project A, we can get the 700. That means NPV of project A is greater than NPV of project B, clearly. So according to the NPV, you can go for project B clearly, right? But question comes when you can calculate the IRR. So calculating IRR, you can write this as simply IRR. It's very simple to calculate IRR in Excel. So here is your cash flows. So yeah, it's 16%, right? 16%, right? You got it, the 16%. Okay. But now look at the IRR of the project B. So IRR of the project is 16%, right? And IRR of project B is 12.94%. The problem arises here. Okay. Now question is, what is IRR? You understand what is IRR? And IRR बोलते क्यों हैं?
IRR is rate where NPV is 0.
NPV is 0. Great. Anyone else? IRR is the rate where NPV is 0. That means IRR is basically the where present value of NCI equal to present value of NCO, right? Understand? The IRR will be that rate where the NCI, the present value, that means present value of your cash flows will be equal to the present value of your cash outflow. That is the IRR is, okay? So in our project, that means IRR is a very important tool in capital budgeting that we are going to consider when we take the decision, right? So here we can see this NPV of the project A is NPV of project B is greater than NPV of project A, but IRR of project A is greater than IRR of B. So problem is here. So now on which and which capital budgeting tool give us the right direction? Here is the problem, right? So according to the NPV you can go for the project B, but according to the IRR you can go for the project A. But here is the dilemma is, so which will be our decision making point? So in this connection, in this situation, what you can do?
Incremental.
We have to calculate incremental. So what is incremental? What is incremental?
So where one project, when one project, one product is given as higher value than the project B.
Not exactly. Additional benefit that comes from the taking new project. So or additional amount of money we have to invest for taking the new project, or additional cash flow we can get by taking the a new project. So that is all about incremental. But here incremental is very simple. We have to calculate the incremental cash flows, cash inflows and outflows for both projects. So what you can do, we can write only B minus A. That means the incremental, right? B minus A. So how to do it? Simply, simply this, right? Project B minus project A. Okay. So here is 0. That means the 0 because of the cash outflow for the two projects is basically same. That is 10,000 each, right? So we got our incremental cash flow. Yes, please.
So why B minus A? Why not A minus B?
Yeah, basically you consider that project B is large. We have to invest larger amount. If you do this A minus B, it will come with the same result. No problem with this. So if you have a confusion, I can calculate all this. Also this one. Look at this. Basically, we used to do it when we actually face the scale problem. So in the scale problem, say one project A is with you have to invest let's say 5 crore taka. In project B, you have to invest 10 crore taka. So which project is larger? This one, right? Bigger project, right? So in this connection, we have to do this B minus A to get the incremental NPV, incremental IRR, so that you can take the decision easily. Okay, so you can do also A minus B. It will come, give you the same result. Don't worry about it. Okay, so we got our cash flows. So we simply calculate our NPV and IRR. Same.
Sir,
Yes.
for scale program, we will decision the project size, project which project large, which project small.
No. Here, that is none of our debate here. Our debate, we're actually going to calculate just simply incremental NPV and IRR, okay? So we can do it accordingly like A minus B or B minus A. That does not create any, different here, okay? So we only consider this on when we face any problem related with scale issues only, okay? So what will be our NPV? NPV is, clearly NPV is $82 or 82, more than 82, okay? And IRR is 10.55. So if since our, cost of capital is 10%, so we can clearly say we should, go for the investment. Now we can take the decision on the basis of, crossover rate. So you can see these things in graphically. So how to calculate it? Say. We have to calculate the we have to calculate the NPV in a different discount rate. So do you know about NPV profile? Do you have any idea about NPV profile? What is NPV profile? NPV profile? Forget. NPV profile is basically showing us the say here is the NPV, right? Here is the discount rate. So if it is the NPV. And here is the discount rate. So say your point is here. That means it shows that in a different discount rate, what is your NPV is. So if the line is like this, that means this line represent that each point of this line represents this. Say this point. This point represent if the discount rate is say for example 2%, what will be your NPV is. Okay. So NPV profile basically reflects us, the relationship between NPV and discount rate. So in different discount rate, you can look at the different NPV. Okay. So we are going to draw the NPV profile for this two project. So that graph will give us the right direction, which method or which capital budgeting tool we are going to use while we face this scale related problem. Okay. So what you have to do, you have to calculate. We have to calculate NPV for the both project. So we can write simply here the discount rate or interest rate, what I can see, discount rate, okay, DR, okay, and NPV of A and NPV of B, right? So if the discount rate is, say for example minus 0.5%, what will be our NPV of A and B? And if it is 0%, and if it is 0.05, if it is 10, it is 15%, or it is 25%, 20%, or 25%. Okay, it's 0. Okay, so NPVs, right? We have to calculate the NPV like previous one. NPV. So our discount rate is here, right? Rate is given here, okay? And comma. And here is our cash flows. Okay, we have to make it fixed, otherwise it will be, we have to fix it by using the F4 function 4 and bracket plus our cash outflows. F4 once again and enter. We got our NPV of 2800 points. 2800. Okay. If the NPV is if the discount rate is 0, then our NPV is 2000. And subsequently you get the NPV in a different rate. Okay. So if our discount rate is more than 20%, our NPV will be negative. So we know because of the cost IRR of the project is 16%. So if the our cost of capital is more than 16%, NPV will be always 0. Sorry, NPV will be always negative. Yes.
Please calculate NPV again.
Okay, so look at the project B. So what we can do is the equal sign, and there is automatically function is there NPV, right? The NPV, and the rate is here. We already give the rate. So in different rate, we want to see what is the NPV position of the two particular projects. So and discount rate and cash flows. Once again, we have to select the cash flows and F4 plus cash outflows. Okay. So here we got our NPV for the project B. So if the discount rate is minus 5%, which is kind of impossible, we want to actually given this 5% minus because we have to show it in graphically. That's why. So yeah, we try it like this, so it will be like this. You can make it a general, so it will come off with a direct figure, and if you make it general, okay. So here you see these three figures are basically negative, right? Say negative means the negative NPV. So if we should try to show this in a graphically, so what do you have to do? Just select this and insert recommended curve and show this. Select this one, and we got our chart, right? So what is this? This is basically NPV profile. Simply NPV profile of A and NPV profile of B here, right? So which one actually representing the blue one representing the NPV of project A, and the red one representing the NPV of project B. So this one is basically red one is project B. So we can draw it simply in our blackboard here. What we are going to do, we are going to actually draw the NPV profile of project A and project B clearly. So here you can use the black one so that it will be much better. Okay, so this is the discount rate, and here is the NPV. So NPV you can write the say this one is 1000, 2,000, 3,000, 4,000, 5,000, and so on. Okay, this is NPV. And here's our discount rate. Discount rate. So say here's a 5% and 10%, 15%, 20%, and 25%. Okay. So now you have here, just help me out. So what will be our NPV if the discount rate is 0? For the project A, what will be our NPV if the discount rate is 0? Hmm?
$21.
21? How? $2,000. How? So say we can simply write here. Okay, if the discount rate is 0 here, it is 2,000. Clear? So how we can calculate this? How we calculate this? Say simply project. So NPV of project A, right? So simply 10,000 divided by 1.0, since our discount rate is 0.
Yes, sir.
Power 1,000, 1.10 square plus 1,000, 1.0 cube minus 10,000, right?
Yes, sir.
So it's basically simply the addition of this cash flows only. So it's 12,000 minus 10,000 and NPV is 2,000. Okay, so you understand, right? So that means if the discount is 0 for project A, our NPV is 2,000. Clear? And when our NPV is 0, what is the discount rate? That means what is the IRR of the project A? We know this IRR is the rate where NPV equal to 0, right? NPV is the debt rate. Sorry, IRR is the debt rate where the NPV is 0. Okay. So if we try to draw this in this line, if anything belongs in this line, that is the reflecting the NPV is 0, right? Say here, that means if the discount rate is say 7%, NPV is 0 for the project A, right? We're clear about this, right? Okay. So what is the cost of IRR of this project A? What is the IRR of project A? 16.05%, right? 16.05%. So you can draw here 16.05%. Okay? Got it? So you can simply draw the draw this line like this way. Okay? So this is the NPV profile of A, right? So accordingly, we have to draw the NPV profile for the project B. So what will be our NPV if the project discount rate for the project B is 0? What will be our NPV? If the discount rate is 0, 14,000 it is clearly. Say simply look at 4,000, right? And what is the IRR? IRR is 12.94%. Okay. So 12.94%. That means if the discount rate is 0, the NPV will be 4,000, right here. And the IRR of this project is 12.94%. Okay. So IRR is the rate where NPV is 0. That means anything belongs to this line is basically IRR 0. Okay. So what do you have to do? We have to just add these 2 points. Okay. So this is the NPV profile of B, right? And this point, the crossing these 2 lines is basically crossover rate. crossover rate. Understand? Okay. So crossover rate is basically the rate. This is the incremental IRR. We already calculated this, right? We got this incremental IRR in last Excel calculation. So if you look at the incremental IRR is 10.55%, right? So that is the 10.5%. This point is reflecting basically 10.55% basically. Got it? Understand? This point is basically 10.55%. So this is called crossover rate, where the two lines cross each other. Okay. So now question is how to take the decision. Now point is have to take the decision, right? So how to take the decision? So we are going to take the decision on the basis of this point. If anything below, if our cost of capital is lower than our in crossover rate, what will be our decision? If our cost of capital is higher than our crossover rate, and then what will be our decision? So simply, our cost of capital, simply take this example, say our cost of capital is 8%. So if the cost of capital is 8% of NPV of project A is greater than, NPV of the project B, NPV of the project B is greater than NPV of project A, right? Clearly. And in earlier example, we got this NPV of B is greater than NPV of A, right? Right? And IRR of A is greater than IRR of B, right? Understand? Okay, see. So here also we got that NPV of project B is greater than NPV of project A. So in this connection, we always go with NPV. Because of here, still IRR of A is greater than IRR of B. If our discount rate is 8%, then our NPV is greater than NPV of project B is greater than NPV of A. So we should follow the NPV, not IRR, to take our decision. Understand? Now, if the discount rate is higher than our cost, crossover rate, say simply it is 12%. Say it is simply 12%, okay? 12% our cost of capital. So if the cost of capital is 12%, that means NPV of project B, right? Or project B. Yeah, project B is lower than NPV of project A. See, the project A is here, right? So simply the NPV of, so here you see the NPV of A and NPV of B. So you clearly see the NPV of A is higher than NPV of B. So that means what you can take the decision, that means you should go for the project A. And our IR also gives the same decision, right? I also say this NPV of A is greater than NPV of project B. Understand? So what is the conclusion? Conclusion is if our discount rate or hurdle rate is higher than our cost crossover rate, then NPV and IRR will always give you the right information or right direction, right? If it is lower than our crossover rate, if our discount rate is lower than our crossover rate, then NPV and IRR will give you the misleading information. So in this connection, in this situation, what we will do? We will consider only NPV. Understand? So that's why NPV called the best among the all capital budgeting tools. Because of NPV and IRR, there are a lot of debates going on. So which project or which capital budgeting tool is better, or which one is best to consider? So in this connection, we always come up with the NPV, because NPV will give you always the right information, perfect information. Understand, everyone? Okay, so thank you.
Thank you, sir.
Okay, welcome.